Today's video, we will focus on limiting reactant, also known as a reagent, and the excess reactant or reagent. Now, the limiting one is going to be the one that ends the reaction. It literally limits the reaction or the amount of product that you'll be able to make in a chemical reaction. Our excess is the opposite. An excess is going to be the one that is left over after the reaction. So our limiting one is the one that is used up, and our excess one is the one that is left over. And you'll see that you actually have to do two different conversions when doing your limiting and excess reactant. Then you're going to compare your two answers. The limiting one will be the lower answer, and the excess one will be the higher answer. So just to review, the limiting one limits the amount of product that you can make, whereas the excess is not all used up. So there's excess or leftover after the reaction. So let's take a look at an example. If there are 400 people waiting to board an airplane, but there are only 350 seats, what would be the limiting, aka the one that limits the reaction, and how much excess or leftover would there be? So if we have our plane here, it only can seat 350 people. Sadly, there are 400 people waiting out here. So what is the limiting? What is the excess? Well, there are only 350 people going to fit per seat. So we're going to have an excess of 50 pretty sad people that they didn't get on the flight that day. Now, let's start to think about it in terms of chemistry. A typical example for a limiting and excess reactant will give you your chemical reaction here, pre-balance. Then it's going to give you two different scenarios. It's going to tell you how much you have of one reactant and how much you have of the second reactant. Now, the key to doing a limiting and excess reactant is looking at going towards the same product. So if you notice this one, it says if you begin with 1.20 moles of gallium bromide, that's our GaBr3. So I'm actually going to highlight this one here, and I'm going to highlight this one here. That's going to be my first reactant I'm going to do. And it's asking us how many grams of sodium bromide will be formed. So we're going towards this product, so I'm going to cross out the other product. And hopefully you guys are following along with your notes with me. Now, our second statement says if you begin now with 1.2 moles of sodium sulfite, so that's Na2SO4, I'm going to go up and highlight it in my problem. How many grams of the same product, NaBr, will be produced? So we're actually going to do two separate mole to gram conversions. So how many steps are in a mole to gram? It's going to be 3 steps. So let's pre-draw in our 3 steps. Now, the great thing about limiting and excess reactants is that the last step is going to be identical. So the same way that we normally do, let's get our given down first. So we're going to have 1.2 moles of GaBr3 over 1. So we're going to need moles to cancel out on the bottom here. So we're going to use our mole ratio from our balanced chemical formula up here. Don't forget that the coefficients represent how many moles you have. So how many moles of GaBr3 do we have? Good, we're going to have 2. So 2 on the bottom. And how many moles of our product do we have over here? 6. Perfect. So you can simplify this if you'd like to a 3 and 1, but you don't have to. Now our final step is going to take us to grams of NaBr. So we'll need moles on the bottom. Don't forget that it's always per 1 mole whenever you have molar mass in grams. So how many grams are in NaBr? So if we go up here, we're going to have how many Na? 1, perfect. How many Br? 1 also. Don't forget, if there's no number written there, you're going to assume that it's 1. So we're going to add up 22.99 and 79.90. Okay, we'll do a little fast math. 3. Okay, so we're going to write 102.89 grams here. Now our final step is going to be to multiply the top, which means we're going to have 1.20 times 3 times 102.89 on the top. What's great about the bottom is that they've all been simplified to 1. So we're basically just dividing it by 1. Okay, so let's plug it in our calculator together. So we're going to have parentheses 1.20 times 3 times 102.89. So our answer is actually going to be 370.4, but we're going to leave it like this for our sig figs. So we're going to have 370 grams of NaBr. Now we can add a decimal or a bar to the top to give that 0 some significance. Also, don't forget to cross out your units, leaving you with your desired units. Now the great thing about doing a limiting and excess is that you're going to use the same steps that we've already used. The only difference is that our mole ratio is going to change, but our last one's going to be identical. So let's prove it. So now we have 1.20 moles of Na2SO3. We're going to come up to our equation and see that we now have 3 moles of Na2SO3, but we're still going to go to the same product here. So we're going to have 6 moles of NaBr. We can simplify it if we would like to. And then we're going to need 1 mole of NaBr on the bottom per that 102.89 that we've already calculated. Make sure that your units cancel out. That's why it's so key to label everything we have. So now let's put it in our calculator. So we're going to take 1.2 times 2 times 102.89. And our final answer is going to be 247 grams of NaBr. Now that we have both of our answers, we can compare our two answers. So our first reactant, GABR3, gave us 370 grams of NaBr, while our second reactant, Na2SO3, only provides us with 247 grams of NaBr. And then this is where we're going to compare those numbers. The lower one is the limiting reactant. So under a limiting reactant, we would write Na2SO3 as our limiting, so our GABR3 would be considered our excess. Now that's how to do a simple limiting and excess reactant. Now you guys are going to work on worksheet number 1 until the end of the block. You can check your answers with Mr. Schultz or bring them up when you're completed to put them in.